Okay, so for this module, we have a online version of a factorial design fail. So this was just data I generated. Notice that this is um, a two-level design where each of the factors 1, 2, and 3 have just level 0 or 1. They are varying, so F1 has 12 zeros, 12 zeros and then 12 ones. F2 has 6 and then 6 and then another 6 and another 6 and so forth. Then the data is generated so on in that manner. Now notice the response. So it's set up so that the factors 1, 2, and 3 are additive. Then we create the interaction between F1, F2, F1, F3, F3, F2, and then finally the three-way interaction and add in the error. Then run it in a regular linear model with an R, and we get some estimates here. The ANOVA model is also printed here. Notice our degrees of freedom. Every single factor has a degree of freedom 1 because this is just 2 levels for each factor. If you were to look at this, look at where most of the error is, okay? Most of our error is accumulated in these main effect terms, F1, F2, F3. It gets diminished smaller and smaller as we go to the higher order interactions. And then finally, the residual error. So this is causing us to not be able to detect these higher order terms, even though we know that we modeled the data to actually be able to simulate having up to a three-way interaction here. So we see very small, smaller than 1 F values here. These are pretty moderate level, right at 0.05. No accident because of how the data was generated. And then these are the most extreme cases. So I would have, if I were to look at this, I would have just assumed that we had a fully additive model. However, what does Gary say? If you believe interactions exist, then include them in the model. If you do not believe that they exist, then include them in the model. So who knows what I would have done in practice had I seen these results. Let's look at a plot though also. We see for the various different combinations of F1, F2, F3, that there is a three-way interaction. In fact, when all 3 levels are at the on setting, meaning 1, we see a magnified response in Y. When all 3 settings are at 0, we see a much, much lower response in Y. So this is a case where our ANOVA table, due to how I kind of in a tricky way generated the data, is not going to detect it. So this just points out that it's also necessary to plot your data. And also I remember reading Gary's advice of, if you think interactions are present, use them. If you think they're not present, use them. And I thought, well, that's kind of maybe just his bias. Well, you see with this example how important that is, because had I just gone with a main effect model and not plotted the three-way interactions, I may not have seen this effect here. Think about this some more and ask me questions outside of class if you have any.